have less ability to absorb carbon dioxide. Now, I want to be really clear about something. CO2 is the primary human contribution to warming. As a molecule, it's about half of the total heat we add to the atmosphere. But remember that CO2 comes from everything we do. A little bit of everything in your life is CO2. The extraction of the materials, the shipping, moving you around. CO2 is the cost of modern life, especially electricity, heating, and transportation. But there's a little CO2 in everything in your world. So it's not very easy to quote-unquote fix the CO2. Methane comes from anaerobic digestion, as you know. That would be from garbage, from wastewater, but primarily from livestock. And that's sort of the bummer but exciting news. That is really easy to fix. Do you guys realize that the biggest reduction an average American could make in global warming would be to just go vegetarian? More than switching your car, more than riding a bike, more than anything else, the single biggest wedge is the meat in the average American's diet. I'll explain why in a minute. Nitrous oxide. Nitrous oxide is the result of fertilizer reactions in agriculture. It's soil nitrogen cycle stuff. Ozone is a secondary pollutant. It's made by other things we put into the atmosphere. And the fluorinated gases are entirely man-made. These are products of industrial chemistry, coolants, aerosols, making microchips and making foam and styrofoam. Now, if I said, don't have a share of industrial chemistry, it's difficult to do something about that. If I said, don't have a share of transportation, it's very difficult to do something about that. But the number one thing that you can do, if you want to address global warming, is cut your meat consumption. Because look up here. There's a lot of CO2 produced in meat production. The chemistry, the shipping. The deforestation, there's a lot of nitrous produced because of the fertilizing of the food you feed to the cattle. There's a lot of ozone produced by all that transportation. And so, the funny thing is, the biggest total wedge of your global warming footprint is the meat in your diet. And a close second is the transportation of food for a long-distance diet. Yeah?
So maybe instead of going as drastic as just cutting it out 100%, how about like eating local only?
Oh, dude, so we don't need to go drastic for anything. Choose local when available, like a 5% reduction in your global warming footprint. Cut down one meat meal per week, like 5% reduction, or 7%, I forget what it was. Like, these are all incremental. You're never going to get to zero. Just by being Americans, the virtue of our material footprint, just like living here, you're already right around or over the global human average. Then you add our flight usage. How many of you have flown a flight more than 60 minutes in the last year? Do you realize that globally, one of you would have raised your hand? As a human average, 3%. Let's do that again. How many of you have done a flight over 1 hour in the last year? Has anybody not in this room? Okay, globally it's the exact opposite. More than half of humanity will never touch an airplane. So then, what I'm saying is the increments are, you've got a huge global warming debt just because of the material wealth of our life. The extraction of all this stuff makes more global warming than most people's all other choices combined. Then the wealth of our diet and the global distance of our diet is like next level. Then we've got this car culture, and our cars are bigger, and we drive them further, and this airplane thing. Every American on average, and by the way, none of us are average Americans, I think. We're probably, most of us are above the average for America. As a global average, an average American has something like 12 or 15 times the global warming footprint of the average human being. So if you want to cut that down, number one, shift your diet. Less meat, more local. Number two, just your driving habits. Whichever car you've got, if you drive it like an a-hole, you're causing global warming. Like when people start like racing in a Prius, like you're not fixing anything. I got passed by a Prius going uphill on Highway 154 the other day. Like the irony is so right. Driving habits make a huge difference. How often you drive and how carefully you drive, how much junk you carry in your car, how often you take turns driving with a neighbor so that one of you can park your car. There goes your car footprint by 50%. Just by splitting the drive with, somebody who knows how to drive, hopefully. Cutting down on the flights is really big. We wealthy Americans tend to travel a whole lot more by airplane than anybody else on the planet. Okay. Anybody want to talk more about this? Cool. I'm going to skip 22 for a couple minutes. Well, no, we can do 22. No, I don't want to do 22. Let's do number 23 really quick. This will go really fast, I hope. It's confusing because up on the screen, El Niño's on the top, but on my whiteboard, El Niño's on the bottom. Please look up. This is Ecuador, right here. This is Indonesia, right here. I'm going to take the planet, I'm going to slice it at the equator, and we're going to look at it from down here. So we got Indo, the equator, and Ecuador. Everybody got that? Here it is. Aren't you glad you looked up? Indo, the equator, Ecuador. Now, the normal thing, La Nina, which is on the bottom of the monitor, is that we get these strong offshore winds flowing off the Ecuador side of the Pacific. This makes trade currents and trade wind, which pushes hot surface water over to Indo and draws cold bottom water upwelling on the eastern side of the Pacific. Sabina's fact-checking us on the internet. She'll let us know that that's all accurate. It is, right? Thanks. Now that we've settled that, don't need the phone anymore. Indonesia ends up getting all the evaporation. And if you think about what you've probably already heard about Indonesia, it's really wet, rains a lot, lush green forest, tropical waters. That matches your understanding of Indo, I think. What a lot of people don't know, because not many people visit Ecuador, is that Ecuador is actually extremely dry. It's very desert-like. Because the air comes back over, this is a convection current, cooled and dry. Also, what people don't know, because very few people visit Ecuador, is that the ocean is actually very cold in Ecuador. Of course, it's still in the tropics. So if you're in stagnant, shallow water, yeah, it's super hot. It's like 85 degrees if you get like a little lagoon. Anybody here done scuba diving at the Galapagos Islands or even snorkeling at the Galapagos Islands? How far were you from the land when you were from the islands when you were there? Did you scuba or snorkel? Were you in shallow water or did you get out a little bit?
Probably got out a little bit.
The water cool off a lot?
Yeah.
Were you wearing a wetsuit?
I don't think
How long did you stay in the water?
so. I don't really remember. It was kind of a while ago.
Fine. I ask because people who scuba dived in Ecuador usually had to rent a wetsuit because you never think to take a wetsuit to Ecuador, but the water is actually exceptionally cold. For scuba diving, they tell you to take a 5 or 7 mil wetsuit, which is what we were here in Santa Barbara for diving. What's surprising about Ecuador is because of that offshore wind, most of the open water is subject to upwelling. It's extremely cold. Little shallow parts near land, of course, it's still the equator, the sun warms it up. So if Sabina had just been paddling around in 12 feet of water, it would have probably been pretty toasty. But as soon as you get out to 30, 40 feet, it gets really cold. This is normal. This is usually the way it works. Every now and then, and nobody knows why, the wind mysteriously turns off. Yeah.
That happens naturally.
Yeah. And by the way, every year we realize we know less than we thought we did about El Nino. 5 years ago, 10 years ago, we had some near certainty about the El Nino rhythm that is now not believed to be. Now people don't think it's rhythmic anymore. And 10 years ago, we thought that this was affecting the global conveyor belt. And today we realize that the global conveyor belt may be affecting El Nino cycle, the other way around, because of the deep sea current circulation heat exchange mystery. Yeah?
Then are fisheries way more productive off of Ecuador than the warm waters are in Indonesia? Or not really?
Absolutely. Ecuador ocean has spectacular fishing. And by the way, the name has something to do with the timing. Like this usually ends when their summer starts, which is Christmas. So I forget what it is, but something about the timing. Like this shuts down at Christmas while the fish come back, so it's a gift of the baby Jesus. It's like, oh, here it comes. Now we get our fish back. And so something about the El Nino thing, the El Nino of this is the baby Jesus because of the timing about the return of the fish or something.
So the wind picks up again and so the fish come back?
Something like that.
So long happens.
La Nina is normal. El Nino is the fluke of abnormal, mystery. Nobody knows why. What happens is, wind shuts down, so there's nothing pushing away the hot water and nothing drawing off the cold. Watch. No upwelling, because there's no more wind. No trades, because there's no more wind. So you get a still ocean, because there's no more wind. In a still ocean, all of that hot air rises in the middle. So look what happens. Relatively speaking, it's colder and less rainy here, but there's more heat and moisture on our side of the atmosphere here. What you probably know about El Nino is their hotter summers and wetter winters. There you have it. You can see that in El Nino, all that hot water that used to get pushed away stayed on our side. Look at the Santa Barbara, the California coast. Look at the South American coast compared to the normal. El Nino is devastating for fisheries of the Pacific because there's less upwelling, so there's less productivity in the ocean, so there's less fishing. And El Nino is devastating because of the drought in Asia. Now, remember I was telling you about the relationship to the global conveyor current? I don't want to get into it for the whole class, but notice that there's more rain in the Indian Ocean because more of that hot water comes up here. I think that there's less upwelling, so there's less upwelling. So people are trying to figure out what the relationship is between the global conveyor currents and El Nino.
So what happens in Ecuador is sort of like what's happening in Africa. It's getting where it's normally dry, it's getting more rain.
Yeah, where there's normally upwelling and stuff. like to add vocabulary term. It's called modoki. And that's Japanese for neither here nor there. So-so, in between, halfway. You guys know that the Japanese have a very close relationship to the ocean. Japanese eat more seafood than any other developed nation. The Japanese have more of their economy tied to seafood than any country on earth. So the Japanese pay very careful attention to what's happening in the ocean. And they noticed one year that it started like an El Nino, and then the wind picked up and it ended like La Nina. Halfway, in between. Starts El Nino, doesn't finish El Nino. It's called modoki. Halfway, neither here nor there, in between. Where it starts El Nino and then ends La Nina, all in the same year. Being that you guys pay attention to the ocean, did you think about anything I misstated or I should add?
No, it's pretty good.
Quickly, I'd like to talk about positive and negative feedbacks of climate change so we know what to look forward to.
What number is this?
Which one? Feedbacks?
Yeah.
That's number 22. What? Actually, I probably will not. No. We can talk about it during the end of the year.
Really?
Yeah.
What's the word in the parentheses in La Nina?
Convection. Okay. Oh, all right. How do-
Diego.
So, watch this. Positive feedback. You look very mature in your button-up long-sleeve shirt, buddy. Very nice. And negative feedback. That shirt makes you look skinny, bro. Okay. Is this what we mean by positive and negative feedback? No, that's not what we mean by negative feedback. Nope.
I like good.
What is positive feedback?
Like a chain reaction.
When it keeps going, chain reaction, where the outcome causes more of the cycle. Where the outcome is self-perpetuating, causes more of the cycle. That's positive feedback. And negative feedback is what?
Opposite.
That's right, where the outcome stops or slows the cycle. Now, for a long time, people have imagined that climate is self-regulating. So the outcomes will cause some sort of a regulatory function. More heating will make some sort of a cooling. And we've always been afraid of the idea that more heating would just cause more heating. It appears that there are negative feedbacks, which is good, meaning that global warming leads to global cooling. Sadly, it appears that those have limits. And once you get past the limit of negative feedback, the positive feedbacks still keep going. That's the tipping point. It's called the feedback tipping point, where warming makes cooling for a while, but eventually those can't offset the warming, and then you get more positive feedback, and then we all freak out and die. There's a key distinction you have to keep in mind. Global warming, when it's happened historically, happens very, very slowly. It's gradual. It's subtle. So negative feedbacks can combat gradual warming. The reason we're all freaked out is because our warming today is not gradual. It's more sudden than the known history of climate. And it appears that the negative feedbacks are too weak, and the positive feedbacks really pick up steam when warming is sudden. So, negative feedbacks, CO2 fertilizes photosynthesizers like plants and algae. So if we get more CO2, you get more photosynthesis that'll soak up all the CO2 and store it up. In small amounts of CO2, that works. If we'd gone from 280 to 320, we would have gone back down from 320 to 280 in under 100 years. It's pretty awesome. A little bit of extra CO2 just makes more stuff that soaks up and then locks in the CO2. It is a natural negative feedback to have a little extra bump in carbon dioxide because it makes more photosynthesizers that store it better. But unfortunately, we've added so much CO2 that there isn't space for that much photosynthesis. We've gone past that. Number 2. If you get more global warming, you get more water vapor. And if you get more water vapor, that should make more snow to reflect sunlight and more ice particles in the air to reflect sunlight. Negative feedback. Water should increase albedo. That make sense to everybody? But you can only do that if temperature doesn't change a lot. We have, again, increased temperature so much that instead of making more snow, we actually get the opposite. We get rain falling on top of snow, which increases melting and lowers albedo. Bummer. I'll come back to that one later. And number 3, what is number 3? Let me check my notes. Oh yeah, we hope that more clouds would make more ice crystals in the air to increase albedo. For reasons I don't understand, this was sort of a mystery question when we first started to study climate. We've determined recently that most of that new moisture, the extra moisture, doesn't make high altitude clouds, which are icy. It makes low altitude clouds, which trap heat. So we were hoping for high altitude clouds, which increase albedo and would be negative feedback, but that's not what we got. What we're in now is a world of positive feedbacks, where first of all, extra clouds tend to be low and they trap heat and cause more warming. Number 2, extra water vapor doesn't make more snow, it makes roses, rain on snow events. New vocab, you gotta write that down. It's called a rose, rain on snow event. All that extra moisture doesn't fall as snow. On a heating planet, all that extra moisture falls as water. And everybody knows that when you drop rain on snow, the snow melts faster. So instead of turning that extra water vapor into extra snowpack, we've turned that water vapor into extra melting, which lowers albedo and we get even more warming. In snowy parts of the world, the number of roses is increasing. The number of rain on snow events is increasing. So snow is melting at a faster and faster rate because on a warmer planet there's less snowfall, there's more rainfall. That should make sense. And this might be one of the most frustrating things of all. We use more air conditioning and more heating because the weather is more unusual. So we make more greenhouse gases because we're dealing with global warming or with climate change. The last positive feedback is the really scary one. You heard about this in the energy unit. Anybody remember what it's called? I said, look, it's not much of an energy source, but we'll come back to this in the atmosphere unit. Really scary positive feedback.
Methane gas.
Methane hydrate. Remember that ice that trapped methane? So when you have anaerobic decomposition and ice formation, methane is locked up in ice, like in the permafrost. Now that the permafrost is thawing, it's releasing greenhouse gases directly to the atmosphere. The really scary one is methane hydrate. There's a lot of methane locked up in ice. There's a lot of permafrost, and there's a lot of organic sediment frozen at the bottom of the ocean and near coastal areas. When that sea ice and permafrost starts to thaw, we release tons of methane to the atmosphere. There's a tipping point at which we cannot stop global warming, and it seems like we're right around there. Where even if we just disappear, global warming continues to get worse because of these positive feedbacks that get going. We were optimistic for the negative feedbacks. They're real, but they seem to be limited to small amounts of heating. The amount of heating we've made sort of jumps over the negative methods and just starts to snowball the positive feedbacks. Anybody want to talk more about feedbacks? If not, I'd like to start study goal number 24. I don't think we'll finish it today. Number 24 is about how global warming will affect our planet in the long term. Now, you guys realize nobody can predict the future. And if you pay attention, there's some really wacky global warming predictions. Anybody find some wacky ones when you were searching today? Like,
not wacky, it's kind of sad apparently that it's going to make the really dope waves in Australia a lot smaller.
That's right, because sea level will rise over the coral reefs. A lot of the famous surf spots are going to shut down. I have surf Cloudbreak and restaurants, so I'm satisfied.
Before or after they opened the waterways?
That year. A couple years ago. So it was the year after that. Yeah.
It's making mountains taller.
It is making mountains taller because they're lighter. There's less glaciers on them. So the rate of continental uplift has gone up. Yeah.
In parts of the U.S., the winter fashion industry has done more poorly because it's warmer longer.
Wow. Okay, didn't know that. Yes.
As far as storms go, they're going to be more extreme, but less of them. So you'll get like a week of just sort of followed by a month or 2 month cloud spell.
Followed by in Santa Barbara, 6 months. We hate surfing in Santa Barbara. Yes.
I got by 24, rain or storm, rainfall intensity will increase by 20%.
Yeah, that's right. Remember that one of the funny things is that we've destabilized weather. So if you used to get rain, you'll either get droughts or you'll get a lot of rain. But it won't stay the same. Nothing stays the same. Unlikely events become more common in the climate system. So the severity of hurricanes goes up, even though the number doesn't change. The intensity of rainfall goes up. So when it rains more, and then it's more spread out. There's a bigger break between storms. Who else? No more interesting predictions? 5? Yeah?
Will there be any spot in the whole world that will kind of stay relatively the same?
Statistically, it must happen. But more likely than not, wherever you are, things will change. Who else? Nobody else found anything interesting about climate change predictions? These are kind of boring. Maybe nobody tried? Yes?
What about like water levels rising and taking up big cities that are on the coast?
We will talk about that, yeah. It seems like the most safe middle-of-the-road prediction is 20 feet over 100 years. Coincidentally, that sidewalk just outside my door is 21 feet above mean sea level.
You'll be fine.
What could possibly go wrong?
You'll be 100.
Who else wants to talk about this? Yeah.
Will we see considerable change in water level rising in our lifetime?
Oh yeah.
Yeah.
Absolutely. Your generation will see some of the most rapid sea level rise of all generations, because actually the rate of sea level rise will slow down after we've melted most of the land ice. So you will probably live through the most dramatic sea level rise. Your children would see relatively less. You haven't noticed it, there's already been a bit.
You said it was going to be 20 feet in 100 years?
That seems to be the middle of the road estimate. That mean sea level will go up by 21 feet.
Before I just looked at something, you said like 8 inches.
Yeah, some people say 3
Maybe that's the
inches.
last 100 years, I'm not sure.
Some people say 3 inches. Some people say 3 feet. I've heard predictions of 30 feet. But I think what's considered to be the most recent consensus is 21. You know, sea level would be 30% more high. So we would have had a third again more sea level rise than we have, except most of the land ice that's melted is trapped by dams. There's so much more water living on dams that it hasn't made more sea level, because globally we've been filling dams at the same time. Once those dams go full and that water cycle returns to flowing both ways, then there's going to be this flood of accumulation as the water starts living in the ocean again. And that's why I said that your generation will see that change, because all those new dams are mostly filling right now. So there's going to be a rush of sea level rise that you haven't seen a bunch of sea level rise, because that's mostly being stored in dams right now. Who else? Okay. So I've got a prediction of 11 interesting climate outcomes. Most of these are considered to be really safe predictions. I'm not going to tell you a 257% change. I'm going to tell you like a very safe estimate. I've got 12 changes that are considered to be safe predictions. Number 1. I would sure think so for number 24, 2 stars. Number 1, global weather patterns are already changing. Like we said, extremes become more common. It's not a single direction. Remember, Europe gets colder. Remember that Alabama just got snow. It's just that weather systems destabilize and extremes become more common. Some areas get wetter, some get drier, some get hotter, some get colder. Very few stay the same. Yeah.
Another kind of crazy thing I saw in the news, it's global, cooling. The Lake Michigan is like 97% ice right now, or 93% ice.
I didn't know it.
Almost completely frozen over.
I didn't know it. Number 2. We called it ecosystem shear earlier in the year. The main impact on biodiversity is not that it's too hot. Remember that there is very little chance of a species not surviving a little heat. There's no reason to fear 1 degree warming, except that all the species respond in a different way. So the caterpillar becomes a butterfly before the flowers, and then they both go extinct, because the caterpillar lost its food and the flower lost its pollinator. It's not the heat. It's called ecosystem shear. We talked about this. That different parts of the food web can take it, but they respond differently, so they just don't line up anymore. The bird loses its habitat. The flower loses the pollinator. The insect loses the food source. Number 3, we've already started to see this. Agricultural productivity goes down. In some cases, this is reversible. Like, hey, you just learned how to grow something different. But the scary part, remember what we talked about grasslands earlier in the year? That they've got really good dirt because of all the rain? Now remember, what happens if the rain belt shifts to the desert? Does that help you for food production? In 10,000 years, yes. For a long time, no, it doesn't. Because desert with a lot of rain is still not good enough dirt for food. All the good dirt now doesn't get the rain. That's not good for food. So, weather for agriculture will move away from the soil of agriculture. That's not good. Number 4, the water supply goes down quickly when glaciers disappear. And I think all of you know that our glaciers are disappearing very quickly. You live in California, so you've probably noticed how important snowmelt is for our water supply, right? You guys all heard this? That our state is running out of water because there's not a lot of snow in the Sierras? How many of you are aware of this phenomenon? Keep in mind, 1/3 of humanity gets their water from glaciers. You know, India, China. With less glaciers, there will be less surface runoff. With less surface runoff, there will be a diminishing supply of fresh water for a lot of humanity. We have a significant reduction in water supply with less ice on land. Number 5, this is the deadly one. This is the really scary part. You can ask the World Health Organization and the Centers for Disease Control. We are entering the sickest period in the history of our species. Diseases will become a much bigger problem. Primarily because diseases show up in new places. Areas that had malaria for 100 years, they all recognize symptoms of malaria. They all sleep under mosquito nets. They all have a good supply of malaria medication. The doctors know what they're talking about. If malaria moves into Santa Barbara, we've got top-notch medicine, right? But how many of you have mosquito nets you could stretch over every bed in your house? How many of you can recognize the mosquito species that spread malaria? How many of you know what the symptoms of malaria look like if one of your children gets sick? Or one of your kids or your neighbors or something? You realize what I'm saying? It's not just about how good you are at medicine. It's how familiar you are with your diseases. The same way that monarch butterflies are shifting their range, so are disease organisms. Whatever we've got will shift to Mexico or shift to Washington, and we will get new diseases that we're not used to. You guys realize that West Nile virus has now reached the Ventura River, right? My parents met the guy that was the first death from West Nile virus in Irvine. They used to walk their dog with that guy. 7 or 8 years ago, my brother was visiting New York City when they realized there was the first West Nile outbreak in the Americas. It went down the East Coast in a couple of years, across the Mexican, like along the southern end of the United States in 1 year, and they've been moving north along the West Coast. We will soon have an African disease in Santa Barbara, 1 or 2 years away. This is what I mean. New diseases in new places. Number 6. Sea level will rise. The majority of that sea level rise is caused by what? Anybody know? No! Glaciers melting causes about a third or less of sea rise. Most of sea level rise is from what? Nope. Yes, and what's that got to do with it? Warmer water is bigger. It's called thermal expansion. The molecules are more active, so they push away from each other, and ocean grows. The same amount of water at a higher temperature is a little bit bigger. That's why sea level rise will change so much in your lifetime. Because the rate of temperature gain is going to be fastest in the next 60 years or so. So as the water gets hotter, it gets bigger. It doesn't take a lot of extra water. It's mostly just the water growing. And does anybody know why icebergs don't add to sea level when they melt? Right, they're already equalized for displacement. That 10% of the glacier that's out of the iceberg that's out of the water, that fits into the volume occupied by the other 90%. You can try this at home. Take a glass, fill it with water, add ice cubes. The ice cubes will be floating. When they melt, you won't have any extra water on the table. Because those floating ice cubes displace into the same volume as the part of the ice under the water. So melting land ice, like glaciers, that does add water, but the majority is from thermal expansion. Number 7. Very possibly the biggest problem in the long term is one we haven't talked about yet in the class. About 1/3 of the planet's new CO2 is not in the atmosphere. Anybody know where it went? It dissolved in the water of the ocean. It's called ocean acidification. Remember, oxides plus water equals acids? Carbon dioxide plus water equals carbonic acid. The ocean is getting more acidic, and it's getting more acidic very quickly. Ocean pH is extremely important to things which have a shell. There's been a collapse of shellfish fisheries in many shallow water regions of the world. A lot of sea scallop fishermen report that they're not finding any more legal sea scallops, or that the sea scallops are getting more sick because their immune system goes down in acidic water, or that sea scallops are being eaten more by octopus and other animals because their shells are getting weaker. Coral has slowed its growth in many places. Oyster farmers can't get oysters to grow anymore because in a more acidic ocean, it's harder to build your shell. As a long-term consequence to humans, ocean acidification might be the biggest problem because the ability of the ocean to produce food is going way down. We're worried that an acidic ocean won't be as productive. We'll start here tomorrow. I left off getting ready for number 8. Yeah, Grant?